So hello everyone, my name is Ondrej. I'm going to be talking about data loss, and since I don't have that much time, only 25 minutes or so, I'm going to jump straight into this because my description of who I am, what I do is on the website, and I've already been introduced anyway. So when we talk about data loss, there's quite a few postmortems online of large companies describing how they lost a lot of data in some incidents. And these often involve databases and environments. So things like, oh, we thought we were doing something in our development or staging environment, and we're dropping a few things, and we are actually connected to a production database and dropped a whole bunch of data. Or you want to delete a subset of your data in a SQL database, but you forget the where clause. So instead of deleting a subset, you actually delete the whole thing. Or my favorite, you have some sort of a bad crash, and instead of using your backups, you are not using your backups because you don't have any, or you have backups but you haven't really exercised the whole scenario of using the backup. So that's, for example, what happened with GitLab. They had like 5 backup systems, but they also failed on the night that they actually crashed. What I want to talk about instead is losing data without actually noticing it. This is for data pipelines and data engineering systems where everything's running smoothly. There are no errors. There might not even be any warnings, and there might not even be any nulls in your data, but you're actually losing data whilst these are running. And these are all stories from my actual work. The examples that I'm going to be showing are going to be a little bit contrived, but the issues at hand are going to be drawn from experience. The underlying theme of this whole thing is how a system, this could be like a parser, this could be a database, this could be a data processing engine, how does it handle incorrect inputs? So you can think of it like, let's say there's an int function in Python which converts a string which is a string representation of a number into an actual number. And so int of a 1, 2, 3 is going to give you 123. So then the question is, what happens if you give it something that is not a number? Let's say you give it a string of hello. What is an int of hello? So there's basically 3 things that you can do if you implement a function like this. Either you can fail, which is basically you raise an exception, you exit the process, you burn whatever it is in your environment. Or you can return null, which is basically saying, hey, I can't parse hello as a number, but let me give you a none or nil or null or whatever the sentinel value for null is in your system, just as a sort of a, hey, I don't want to crash, I'm just going to give you none. And the third option, my favorite, is to parse it incorrectly. So you might have this hello, and the system might be like, oh, that sounds like a 7, so I'm just going to give you 7 as a result of int of hello. And these things actually happen, and we're going to go through a few of these. So here's an example. So here I'm creating a CSV from scratch. I'm omitting imports and stuff like that, but just so you know, all the code and a lot more description that I'm giving you here is going to be online on my blog. I'm going to link to it at the very end, and there are going to be even more examples, so no need to sort of take any pictures or copy anything. So here I'm creating a CSV with some names and some dates and whatever that may be, like last birthday or something like that. I did prepare this a few months ago, so this is still 2019. And you may notice that some of these dates don't actually exist. So last year wasn't a leap year, so well, this wouldn't be valid even in a leap year. But 29th of February was not a thing, and April only has 30 days, so this is not a thing either. Here I'm using Apache Spark. For those of you who don't know, it's it was the most active Apache project as of last year, probably still is, and it's one of the most used data processing engines. It has the concept of data frames like Pandas, but also has a SQL interface like databases, and it's very performant and is used for large-scale data processing and manipulation and analysis. And in this case, I'm telling it, hey, I have a CSV, it has a header, and I want you to infer the schema. So here we can sort of exercise the the three options that we have. So I'm telling it it's a here's a date, and it can infer, and it might say, okay, so this looks like a date, but these dates are not valid, so I'm just going to leave it as a string. Or it can say, oh, it looks like a date, but it's not actually valid. So for those that are invalid, I'm just going to place nulls. Or it could recognize as dates, and then upon parsing them, it might just fail with an exception saying, oh, hey, this is not a valid date. I'm just going to give you a second to think about which of these approaches Spark might take. The answer is none of them. It actually chooses something completely different. It actually chooses to overflow these dates. So if you're familiar with the concept of overflows, so in programming, some variables can be said to be integers that contain only values, let's say from -128 to 127. So if you give it 200, it's going to overflow and give you some sort of some small negative number. And this is what's happening here. So we've got 30th of February, which is, if you sort of, I just sort of think about it like how this could happen, because I had never seen this in my life before I saw this in a real life production system. It's actually 2 days after the 28th of February, so it's going to be 2nd of March. And 29th of February is going to be 1st of March, and 31st of April is going to be 1st of May. So the issue with this, apart from it being completely wrong, is that these are valid dates, but they don't conform to these dates. So if you have a system like Great Expectations that was described at length today's workshop, and you check for nulls and stuff like that, these are not going to get flagged up. You're just going to have completely invalid dates without any errors, without any way of detecting that there are problems with them. You might also be asking, like, how could I get 30th of February in my data? There are plenty of ways invalid dates can get in your data sets. Just look at like leap year issues and stuff like that. There's plenty of ways that, or people might confuse days and months, and this could happen. Or you might be thinking, hey, I don't care about that date column. It's just if there's a problem with it, it's going to be isolated to that column, and everything else is going to be all right. And if I've got like an invoice data set, I'm only going to be interested in the client ID, the invoice ID, and the amount, for example, and I want to do some reporting on that. Here is an example of how that might work. I've got a CSV, a very simple one, 3 columns, a bunch of integers. And you might notice here, this is not an integer, it's a floating point, but looks sort of integer-y. It could be an integer if you omitted the 0.0, but technically it is a floating point. And in my schema, I'm going to define it all as integers. This is what Spark lets you do. You can define the schema. It's actually a good thing for you, because then you can sort of impose some sort of a structure on your data set and make sure that what you're getting is not something that's inferred, but it's actually what you give it. So I'm going to give it the schema and tell it that there's a header and let it read. And this is something that Burn does really badly, because then what happened was that it encountered the 15.0 and it wasn't an integer, so it placed a null. But given that the data point didn't conform to the schema, it actually nullified the whole row, which is something that we did not expect at all. And we only discovered this when we started getting like columns that should never, ever, ever be null, like IDs of some events and stuff like that. And there were just suddenly so many nulls in our data set just because some data started suddenly coming in as a different data type, which happens in live production systems all the time. The good news is that the previous and the current, so this example and the date overflow has been fixed. It's been fixed for a few months now, but it hasn't been released. It's going to be released sometime this week. But then still, the issue is that it's been in the code base for years. There's still quite a lot of Spark 2.x code which exhibits this problem, and unless we all upgrade to the newest version, this is not going to go away. My third example is about my favorite data format, and that's CSVs. The previous examples were about CSVs as well, but they were not the star. So this is going to be a bit more about the format itself. So when we think about CSV, we think of a very simple format. We think of it as like, okay, so it's a bunch of values, and they're separated by commas, and the rows are separated by new lines, and that's about it. Let's put that definition to a test, because I've seen this definition, well, spoken out loud, probably not written out, but let's put it to a test. So I'm going to use the CSV package from Python and to write 3 rows to a file. So a header, and then a name with a silly nickname, and an age, again, a name and an age. So there's 2 columns, 3 rows, or 2 rows with data and a header. And I'm going to ask Pandas to read the CSV and give me the average age, which is 56 plus 44 divided by 2, 50, sounds about right. If we ask Spark the same question, we're going to get, and I'm just telling it as a header, and for the schema, everything is standard. I'm going to get 44, which is odd, because there's 2 data points, and it's quite hard to make a 44 out of these 2 data points. So let's look at the data frame. Before we get to data frame, one of my specialties, apart from data engineering, is adding and removing slides minutes before my presentation. So if I'm going to get stumped like I did just now, it's because I've recently added this slide. So CSVs don't have a standard per se, but there's a Professor Commons 4180, which was published a while ago, and this is the closest to a standard that we have. And it defines, apart from the commas and the new lines, 2 more rules that parsers should adhere to. And this sort of reflects one of these rules. The rule is that if you have a quote within your field, which you can have, you need to escape it, just like we need to escape it in Python in a string. The issue is that in CSVs, in order to escape it, you have to put another quote in front of it, not a backslash. Sadly, Spark by default will escape quotes by using backslashes, both when reading and writing data. So if you read some compliant data and write it out, you might mess up your data quite badly. So here we can see that there was an analyst comma, and because it misinterpreted these quotes, it thought that the comma was actually separating the fields, and it just sort of overflowed some garbage into the age column, and the 56 got completely lost. And again, this is something that bit us in production systems, where we just relied on the defaults, and we gave it completely standard compliant CSVs, and we lost these columns of data without actually noticing it. So this is why we get the 44 as the average, because it's only computing it from the one value, and sort of disregarding this whole string here. And now my favorite example. This is the one from the talk description. This is a bit more contrived, but it is there to prove a point. Let's say you have some pizza orders. So there's John, Jane, and Wendy ordering pizzas at some dates, and they order 3, 5, and 1 pizza respectively. If we ask what is the number of pizzas that they order in total, we're going to get 9, which kind of makes sense, because we've got 3 plus 5 plus 1 equal to 9. And this is where we encounter something that's quite the opposite of losing data, and it's actually gaining data. Because if we ask Spark the same question on this data set, I'm also using the mode fail fast, which is not the default, which is basically saying, if you encounter something fishy, just raise an exception and fail. If we ask it how many pizzas got ordered, we get 127,453, whereas in Pandas we had 9. If you ask Google Sheets or Excel or any other, well, probably almost any other processing system, we would get 9. But here we had 127,000, which, if you run some sort of a BI reporting kind of system, this becomes quite an issue, because there's a small discrepancy between what you actually have in your data and what this tool is reporting you. So let's look at the data that we get. So this is just a printed version of the data frame that gave us the 127,000. And we can see that apart from these 3 rows that you saw on the original slide, there's a whole bunch of rows that we didn't see originally, including these 100,000 pieces here, 123 here, and this weird quote here. This brings us to the second rule in RFC 4180, which is saying that, so the first one was, if you want to use quotes, you can, but you need to escape them by another quote. And the second one is, if you want to use new lines, and you totally can, you need to quote your field. So this is not as commonly known as I'd like it to be, but you can actually have new lines in your fields. Like if you go to Excel, and I forget what the shortcut is on any of the platforms. I think it's like Alt-Enter or Control-Enter. You can actually add new lines to your field. So you can have a whole poem in your field, and it can get exported in a CSV into a single field, and it's going to have new lines in the exported material, in the exported file. So how we actually got to this was that we had some sort of a data set from a CRM or from Salesforce or some other system that had one field, one column, which was basically like a note or a comments or something like that, where people could write like free-form text. And somebody wrote like a bunch of notes with new lines and everything, which is completely fine. It got exported to the CSV just fine. But then we sort of counted the rows that we got just to check that we got the same number of rows that we exported from the system. And we had a lot more data that we got from the Spark pipeline that we got from the source systems. And we sort of dug around, and we found out that by default, Spark doesn't really adhere to this new line rule in CSVs, and just parses CSVs row by row, and sort of disregards that they can sort of flow like this. You have to tell it, like forcefully, you have to tell it like, please interpret CSVs and their fields as possibly multi-line values. So I thought I'd play with Spark. I didn't think this would work, and so I just played with it, and I created this data set where I had a note where people just add a note to their order, and I added some legitimate note, and then I just added a whole bunch of rows that look like the data that we have and conform to the schema, but they're just on new lines, and I just ended up with a quote. So this is a completely valid CSV. If you use Pandas, Excel, Google Sheets, it's going to work just fine. It's going to give you 9 orders. But if you load it with Spark, you're just going to get a whole lot of, well, not garbage, because these are actually interpreted as valid data and can be acted upon. So this is really dangerous. And the dangerous part is that we're using some of the most cutting-edge technology for data processing, and it's defaults. I'm not saying that the tool cannot read this file. There's ways you can make it to read the file by adjusting the settings, but by default, it cannot read the data, and it actually can cause harm. It can actually either lose data or add data or and other things. And we're also using the most common data input format. Don't quote me on that, but if you've worked with data engineering and even data science, you see that as much as we have advances in Parquet, RSC, and other binary formats, CSV are still omnipresent for data exchange, because it's so, well, it seems to be so simple to describe your data. And this is not just these CSVs dates. Just for the sake of time, I've only described these 2. But if you look at the article, I talk about quite a few more examples. Here are just some semi-famous examples from other fields, which also lead to loss of data, not in the traditional sense of losing tables, but in a sense that it get misinterpreted. So things like the Norway problem. So if you have a YAML file and you put in no as in the ISO, a shortcut of the ISO name of Norway, then it's going to be interpreted as false rather than the no that you intended. There were some talks about the defaults in scikit-learn's logistic regression that would in some way affect the results. If you work with distributed systems, either as a user, as a developer, you should be very worried about your data, because there's a million ways you can lose data in these. And some of these systems that try to synchronize data between nodes or between multiple systems on potentially multiple machines, they're actually designed to lose data. It sort of sounds weird, but it's sort of it's sort of like how to reconcile that if there's a conflict, and some of them like, okay, look, I'm going to throw away some of the data because this looks more recent. And I talked about CSVs, but parsing JSON is so much more difficult because there's a lot more rules. And there's a great article, as again linked in my blog post, where they talk about different ways to stump various parsers. And there's like no two parsers are alike in terms of like what sort of data they allow to go through. So what do we do now? So there's a few remedies. So I think the top one for me is at the bottom, which is basically you need to be sort of more inquisitive. You have to be sort of more interested in the tools that you're using, especially if they're sort of high-level abstractions. Because one of the selling points of things like Pandas and Spark and databases is that it sort of gives you a lot of power by just using some very sort of easy-to-use language, be it a programming language, script language, and they do a lot of things for you. So if you do pandas.read CSV, it might do decompression, it might do other stuff off the internet, it might infer date types, it might do all sorts of things. But you have to sort of realize this is not very explicit. This is all sort of done automatically, and it might change from version to version. It might change by getting some sort of a new data format your way, and might be misinterpreted in ways that you didn't expect. And you can only sort of get around this by either not using these high-level tools, which is sort of quite a waste of time in most cases. Well, the not using part, or you might have to invest a lot of time in understanding these tools and how they work. And I covered very basic sort of read CSV group by some stuff like that, but these tools can do a lot more. The second thing you can do is you might just be very defensive in your coding. So there are a few options, for example, in Spark that you can set to be more cautious about the inputs. It's not going to sort of save you, but in all cases, but it's going to save you in many of these cases. And you want to be using latest versions of these tools because there are bug fixes that get distributed every day. And as I said, Spark version 3 is a major version release that's been released after years of Spark 2, and it fixes a whole lot of date issues. There's actually even time overflows that I didn't talk about. I tried to make them sort of change the CSV defaults to actually use the multi-line approach and the correct escaping by default. It's been in the issue tracker for about 2 years now, and I was like, please put it in Spark 3.0. It's going to be breaking anyway, so might just break it for the better, but I sadly wasn't listened to. And the last remedy is just taking a different approach to the way that you handle invalid data. This is more from a developer perspective rather than a user perspective. So this is a quote from Jira from one of the issues, where they basically say, where somebody said, "Oh, I've got obviously invalid data, and you parsed it just fine. What's going on?" They were like, "Yeah, we'd rather return null and just let the program flow rather than raise exceptions. Exceptions are for things that are sort of statically incorrect. So you're using a function for use that cannot be used for stuff like that." That's it for me. If I've got more time, I have some other material. But if there's Q&A and we're short on time, then I can stop right now. It depends on.
So far, there's one question, which is whether you could suggest some best practices from data reconciliation between source and destination data, and if there's open source projects about data quality that are usable or maybe contributable.
So there's a few tools. So on a row by row basis, we've been quite happy users of JSON schema. It's sort of more for APIs and for JSON data, but it sort of lets you set boundaries on terms of like min and max values, regular expressions, and telephone formats, email formats, stuff like that. But it doesn't really give you the bigger picture. Like, I want this data to be on average this value, stuff like that. This is what Great Expectation is very good for. It was introduced at the workshop today. I use Great Expectation a little bit. It moves very fast, so your code might break if you write it and then sort of upgrade the library. So it's a very sort of live system. It does a whole lot of things, and I understand about maybe 5% of the tool. But for things like, I want this to be not now 95% of the time, and the rest of the time, I want the median value to be in this range, and these sorts of things is very useful.
Yeah.
And then there's some specialized tools like DEQU, which is specialized for Spark. That's by AWS from Amazon. So there's a few tools. I'm not super happy about either of them. There's sort of different uses. And what I like most is things like, do I have some sort of a ground truth in terms of like a sum of a crucial column, or some sort of property like this has to be distinct, or this cannot be null, and just have these sort of queries that will sort of run through my data on a daily basis or at ingest time, and it will tell me, hey, this is not what I expected. So this is sort of more manual than things like Great Expectations or DQ, but it's sort of very well debuggable, and it's very well implementable. That's a word. So that's my recommendation.
Cool, thanks. And another question by Vincent, which is, what's the funniest story about data loss that you know of?
I'm not sure if it's funny or sad, but it's basically...
Or sad and funny.
Well, things like data, like severe data loss and pipeline problems, stuff like that. And we weren't told for months like that there was an issue. Like there was a pipeline they were building for an internal customer. They were like, yeah, please do it by last week. And we deployed it, and then it was just like spilling garbage all over the system. And we didn't really, it sounds bad if I say we didn't care, but it was not a high priority issue for us. And nobody really cared. And that's how we found out that the pipeline is needless. It doesn't really have to be there if nobody really sort of cares enough to understand that the data is wrong. It's not that they didn't go there, it's just they didn't understand that it was wrong. And so that's where there needs to be more communication. It was a problem on both parts. We should have been more upfront about what it is and how we can deliver the data. They should be more upfront about the use cases and how high quality they need and stuff like that. So yeah, not noticing a data loss for extended periods of time is the sort of the fun sad story.
Yeah. One last question, I think. What's your opinion on building an ML-based data profiling tool for data quality purposes, or have you come across any?
So I'm not really big on ML in general, so this is going to be a bit biased. But what I perceive to be the problem is that there's always people with expertise who know what the data should look like. I'm not saying that if you've got 300 columns, you're going to know about all of them, but there are some inherent qualities. You know that the price with VAT should be greater or equal to the price without VAT and stuff like that, and there should be some sort of range. You can absolutely build. I would advocate for simpler models because they will be better explainable. You can build some models to sort of catch some relationships between your variables, but for the most part, I've been quite happy using rule-based systems because they're easier to build, they're easier to code up, they're easier to version, and they're faster, stuff like that. So go for it. I'll be happy to be told that there are systems like that exist or that work well, and I'll be happy to use them if they're out there.
Cool, thanks.